Hi, I am Dr. Seung-jae Kim. This class is Calculus 1, the beginning of calculus. We'll use my lecture note, which is organized following Thomas Calculus, the 15th edition. Okay, let's begin here, section 1.3, which is about trigonometric functions. I guess you might learn trigonometric functions from your high school. Once a right triangle is given and an angle is selected, and which is x, then this side is adjacent side, and opposite is just opposite side, and that is the hypotenuse. Then the sine, cosine, tangents are defined in terms of so, cot, toa. For example, tangent x is opposite side over adjacent side. You learned, I believe, from high school. And also cosecant, secant, cotangent are defined as the reciprocals of sine and cosine and tangent, respectively. Okay, now here we'll redo it. We'll reintroduce these trigonometric functions. Now we'll begin with angles and sectors. What is angle? An angle can be defined along with the unit circle, the circle of radius 1. In this figure, for example, for the circle of radius 1, once this sect arc length is theta, then we say the angle is theta. Of course, the line segment is made from origin to and some point on the circle. So that is definition of angle. So here, whole circulation is 2 pi. To reason is the arc length of the circle. Whole circle is 2 pi. And theta is defined in this way, in radian, but people are using degrees. So that 2 pi must be same as 360 degrees. So that pi is 180 degrees. So if you consider this one as a multiplication of the number and degree, then degree itself is pi over 180. So you may think that degree itself is pi over 180. Anyway, the theta is defined in this way. So here, for this problem, for example, if you try to now figure the angle of 30 degrees in the beginning, then now here 1/3 portion of the 90 degree will be this one. So that is now here 30 degrees. Okay, let's try to use a little bit thicker one. Okay, now -6 degrees in the negative direction here. So that is here now 2/3 part of right angle. So that is 60, okay, -60 degrees. And 420 degrees, that one is the same as, okay, 360 whole circulation plus leftover is 60. So that is now the same, so that we may ignore this portion and 60 degrees. But anyway, we'll make a whole the degree here is one circulation in the beginning, and 360th and 6 degree more. So that eventually that, okay, that is now 420 degrees. Okay. Now for the final one, that is minus 3 over 2 pi. So that is now, you can consider here now, that's 90 degrees pi over 2. So that minus pi over 2, minus 2 pi over 2, minus 3 pi over 2. So that here you can get negatively turning, becoming that angle, that is minus pi and times 3 over 2. Okay, I wrote down 3 over 2 later, but it'll be okay for you. Times 3 over 2. Okay, but this one can be also changed into the degree. So then minus here 3 over 2 pi itself is the same as 180 degrees. So that one is same as minus 270 degrees. Of course, in this picture, that is minus 270 degrees. Okay, so angle is defined as here now arc length on the circle of radius 1. Okay, that is the definition of angle. And so that if you consider sectors, then usually you are considering sector length, arc length, and area of sectors. Here, in general, the circle will have radius r, but from this small picture, that picture can be considered as just a simple scaling, so that if this angle is theta, then we know that arc length is theta. In this magnification by a factor of r, and simply now the arc length must be r theta. That's the reason arc length of a sector must be r theta. Now, you already know that area of a sector is half r squared theta, but it can be written as now half r L. Of course, L is arc length. So that in this picture, for example, R is like a height, that is R. For every point over there, always the same as R. And this length is now L. So if you consider that one as a bottom, and bottom length times height and times half. So that if you consider area of sectors, then sector is like a triangle. Right? So I wrote down over there, a sector is like a triangle. Anyway, I write down this one for you to memorize better. Okay. Now for this problem, let's try to solve only part B here. Now, arc length L is r theta, but theta must be in radian. So that we have to change this one into radian. R is 4, and 240 degrees is the same as now, okay, that is same as, okay, 180 plus 60 degree. So that the first portion is pi, second portion is 1/3 of pi. So it's the same as 4 over 3 pi. Okay, so here angle in radian is 4 over 3 pi, right? So the answer is 16 over 3 pi. Okay. So far we learned what the angle is and what are arc length and area of sectors. Okay, now we'll go to the basic trigonometric functions. You learned that from high school in terms of SOHCAHTOA. And if you are considering right triangle, then usually it is defined for acute angle, which is less than or equal to 90 degrees, less than 90 degrees. Now, for general angle, obtuse angle, larger than 90 degrees, and negative angle, we will try to define trigonometric functions. Okay, let's begin with here now the circle of radius r, so that for every line segment from the origin to the circle will have length r. Now once hit, this line is hitting the circle, then that one will have x component, y component. But anyway, so that is x value and y value. So we define sine is y over r. Of course, that one is exactly the same as that one along with SOHCAHTOA. For example, if you are considering an acute angle, then that will be here we can make this right triangle. That will make x and y, and of course in this case that will be theta. So that, and here that is now adjusted angle. That is basically opposite side and side, and that is hypotenuse. So that sine theta will be the same as now here that over that one, O over H. So that is so. And CAHTOA is the same. Basically, we try to define the sine and cosine tangent for general angle, but that is the same as SOHCAHTOA, basically. And so sine is y component divided by the length, and cosine is x component divided by r, and tangent is y over x. So basically that is a sort of a slope, and changing x from 0 to the point, and changing y is now from origin to the point anyway. So that is basically a definition which is the same as SOHCAHTOA when theta is an acute angle. And exactly the same cosecant, secant, cotangent can be defined as reciprocals of sine, cosine, tangent. That is the definition now. Okay, here we can evaluate the exact value for these common angles. Sine, cosine, tangent of pi over 4, and also pi over 6, pi over 3. That can be made from here, that right triangles, that 45 degrees, and that is pi over 4 is made from the half of the square. If you expand that one into that square of the length 1, then that's a half. And of course for that one, this is equilateral triangle, and of side 2, and we are considering half. Then you can get this portion. I believe you are familiar with that one. Okay. Now we'll consider a little bit about geometric interpretation of the trigonometric functions we defined. Okay. Now let's go back to the acute angle, so that we can easily see here right triangle. Once ray having angle theta is hit the circle of radius 1, then the position A will have x component and y component. So here, x component is cosine theta, and y component is sine theta. And that is, of course, over there, the hypotenuse, that is 1. And that is geometric interpretation. So cosine is x component, horizontal component. Sine is vertical component. Okay, so you can memorize this one quite easily. Among these COS, SIN, I is only the vertical letter, so that sine represents vertical components. Okay, for tangent, that is defined as y over x, so that, and if you are considering now here this picture, then y changes this one, x changes 1, so that you may say that that is tangent theta over 1, or and y over x can be gotten immediately from sine theta over cosine theta. So in picture, tangent theta means that now that length. Okay, that is geometric interpretation. Okay, now in this example, we want to evaluate the values sine theta, cosine theta, tangent theta for the point here p minus 4 and 3. The x component is minus 4, y component is 3. Okay. Then for the points, if you are measuring r, then that is a square root of, by using Pythagorean theorem, and minus 4 squared plus 3 squared. So it is square root of 16 plus 9, so it's 25, it's 5. Okay, r is now 5. And the point will be here, x is now minus 4, and y is 3. It's a minus 4, and y is 3. So that here, so it's a minus 4 point, and y is height is 3, and that is the point P now. So the angle is now, that is angle, that is a theta. Okay. So sine theta is, sine is always here the vertical component. So that that is, okay, that is now r is 5. So that must be the same as your vertical ratio is 3 over 5. And out of this 5 length, there's a 3. So then there's a 3 over 5. And cosine is a horizontal component. So it's horizontally the point here, minus 4. That minus 4 ratio with respect to the r, the radius, that is now cosine theta. Now tangent theta is slope. Of course, if we write down that one, then y over x. Y is now 3, and x is minus 4. So you can rewrite here minus 3 over 4. Okay? Okay. Here we have frequently used trigonometric formulas. Of course, and sine and cosine are defined as here, along with the circle of radius 1, so that from Pythagorean theorem, and this side squared plus that side squared, addition must be here 1. That is exactly that formula. Immediately from the definition, you can get it. Now, tangent theta, tangent x is sine x over cosine x. And also you may think this one as the slope. Okay. Now here we have graphs. Y called sine x. Start from that 0. Okay. Now let's recall the definition of sine and cosine. Okay, that angle is 0. Okay, then hitting this point. Sine is a vertical component. Now, vertically, the value is 0, but horizontally, the value is 1. So that's reason cosine starts from the value. Okay, so after 2 pi, it's coming back to the same position. Yeah, the same position. And that is exactly the graph. And you can easily see that once it is a pi of 2 over there, then now vertical component is 1, which is at that point. And now, and horizontally is 0. That means that point here. So you can make this picture. Okay. For tangent, it is a slope, so that once angle is becoming larger, 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 and pi over 2 then blow up. And also over there, angle is smaller, smaller, and reach around minus pi over 2, then blow down. So that is exactly this figure. And it is repeating, and with pi period, and it is repeating again, again, again. Okay, here, so we define periodicity and periodicity, and in this way. A function is periodic if there is number p larger than 0, such that the function value at x and x plus p are the same for every possible value. Then in this case, now among those p, and if we choose the smallest one, then that's called a period. So here, sine and cosine, the value must be same after 2 pi. And you can see easily here, sine is the vertical component. The vertical component is now is positive and go down negative and becoming 0. And again, positive, negative, becoming 0. And after 2 pi, it becomes, the value becomes the same. So sine, the period of sine is 2 pi. Of course, the period of cosine is the same, 2 pi. And from this picture also, we know that the period of tangent is pi. So it is here, put these 2 lines. Okay. Now we'll observe a little bit. And if we put the graph of sine and cosine together, then we can see something. Now sine, the red one, red curve, and here, if you think here now x, then the value at x will be this one. But if you consider minus x, then here the value will be that one. So it looks like it is satisfying that line. Sine at minus x is same as minus of sine x. Of course, by using picture, you can easily see that. Okay, the sine is defined as the horizontal component. Okay, sine x, and if you go minus x, then of course if you are, oops, over there, and now sine is now a vertical component, so that this value and that value, this value is negation of that one. You can easily see that, and there's x and this is minus x, then you can easily see that. But a cosine is a horizontal component, either positive x or negative x. The horizontal component is the same, so that it is satisfying that condition. Cosine minus x is cosine x. Of course, over there in the picture, you can see that once it's x, then cosine value will be this one, and minus x also the same height, right? Okay. Another one is that if you are moving, for example, sine x, either in positive direction pi over 2, then or negative direction pi over 2, then it can be either the same as cosine x or negation of cosine x. And also the same in 3 pi over 2, moving left or right, and it will become here either cosine x or minus sine x. That observation makes the problem solving much easier. Okay. Now, we want to simplify this mathematical expression here. So we choose one of these answer. Okay. Now, because once we eliminate that one, which means that we are moving the graph of cosine this function by 3 pi over 2, either right side or left hand side. It's okay. We don't have to specify the direction. Now, the main thing is moving the graph by 3 pi over 2, so that the result must be same as now sine of x. Of course, over there we have to select positive or negative. Now, by specifying one point, you can decide the sign. For example, let's choose x equal pi over 2. If we choose 0, then the value is 0, so that it's not possible to decide the sign. So we choose here x is pi over 2. Then this value will be 1. Now, once x is, now for this term, x is pi over 2, then it will become now cosine, and pi over 2 is subtracted, so that is cosine pi, which is negative 1. So this value must be, whole value must be negative 1, but this itself is currently 1, so that eventually we have to put minus and sine of x. That's the answer. So the answer is minus sine x. Okay. Now, when you try to make graphs of trigonometric functions, you may consider transformation. Transformation is combination of magnification and shifting, and also sometimes we have to find the period. And so in this way, you can make a picture and figure much more easily. Once you can write down, for example, for sine function, and a times sine 2 pi over b x minus c plus d, then in this case, absolute value of a is called the amplitude, because now here you can multiply, for example, 2 or minus 2. But even though you multiply minus 2, anyway, it is amplified by a factor of 2. So that's the reason absolute value of A is the amplitude. B determines the period, and along with the ratio and 2 pi, that will make the period. And C is horizontal shift. You already know that once you are shifting in horizontal direction, then instead of x, you are putting x minus c, which means that it is moved in horizontal direction by c. And also here, plus d, that one can be moved to left-hand side, so that is same as y minus d in this case. So that if we want to move vertically by d, then you replace y by y minus t. You already learned from high school, I believe. So that is exactly the general formula after transformation. Let's try to find here now for this equation the amplitude, the period, and horizontal shift and vertical shift. you can write this one again in this way. There's twice of sine. We try to match here this form. Then first we try to write down half comes out. Then there's x plus basically there's 2 pi. Okay, so here we try to write down again one more time. Okay, and on the top here 2 pi. Mathematics start from definition. And during the computation, you have to match the form. Then it's much easier. Half can be written here 2 pi over 4 pi. So its whole thing is 1/2. And x plus now 2 pi plus 1. If we follow that one, the form, then the amplitude will be 2. And now here period must be 4 pi. And here horizontal shift must be minus 2 pi. And vertical shift must be 1. Right? That means that here, start from original sine x, you are making here now the shift. And okay, first you may try to make some period control so that by using expanding in x direction and later on shift and amplitude and so on, you can do step by step that operations, transformation to finalize the graph. Okay. Now, for this problem, okay, anyway, this portion in finding period and x over 2 is changing from 0 to 2 pi, then the function makes a whole cycle. That means that here this is exactly the same as x is moving from 0 to 4 pi. So by multiplying 2, then once x is moving from 0 to 4 pi, then the function makes a whole cycle, which means that the function has period of 4 pi. We already know that here period is 4 pi. You can find in this way the period. Of course, amplitude is quite easy to find, and also shifting is, shift components are easy to find by manipulating the given function in this way. Okay, now here we have trigonometric formulas, and we already know that one. And then by dividing cosine squared theta, and we reach at that one. And by dividing sine squared theta, we can have that. And this addition formula is not easy to memorize, but we already know sine is measuring vertical components. Once angle is added, then vertically it may not be stable, so that is a sort of a maximum possible complicated combination, sine A cosine B plus cosine A sine B, and quite complicated combination because it's not really stable. The reason I'm saying this one is for you to memorize easily. And cosine is a horizontal component, so that even though angle is added, like you are putting boxes side by side, is stable. So that they are easy. So they make team, cosine team, sine team, then they play tug of war playing, and that's easier. So in this way, you can memorize the formula quite easily. once A and B are the same, then that'll become cosine, sine 2 theta, and then this side will be the same, so that twice of sine theta, cosine theta. Simply from this one, you can get that one, and from this one also, you can get that one when A and B are the same as theta. Okay, now this half angle formula, that comes from this one. For example, now cosine theta, cosine squared theta is same as minus sine squared theta, and we have one more minus sine squared theta, which is the same as 1 minus 2 sine squared theta, so that sine squared theta can be obtained by moving this one to this one to the other side and move the other side and divide by 2. Okay, so that is exactly this one. And again, this can be written one more time in this way. Cosine squared theta and minus sine squared theta is 1 minus cosine squared theta by using the formula over there. So that is same as now twice of cosine squared theta minus 1. And this term and left hand side, and we can solve for cosine squared theta to obtain that formula. Here, the same form, but only the difference is minus and plus. But sine squared theta or sine theta, sine squared theta, when theta is 0, the value must be 0. So that once we are putting theta 0, then it's 1, so that it must be negative. Now, for cosine, once the theta is 0, then the value must be 1, so that now 1 plus 1 divided by 2, the same. So that sine has here negative, cosine has positive. They must be, right? And the law of cosines, ABC are sides of triangle, and ABC are the corresponding angle, opposite angle. Then, now, for example, C squared is same as A squared plus B squared minus 2AB cosine C. Of course, B squared or A squared can be defined similarly. Okay. Okay, among these problems, let's try to solve here number 4. I'll try to give you only hints, okay? For part A, and okay, now for part A, here cosine squared theta is 3 over 4, which means that cosine theta is the same as, now taking square root here, right side is top is square root of 3 and bottom becomes 2. The reason I put here the empty spot is that you have to put here plus minus. Angle is restricted from 0 to 2 pi, but a cosine theta in the domain can have negative value, so you have to put plus minus. Now, by using circle of radius 1, you can make you can find the theta quite easily. Okay, here we have. Okay, it's a radius 1. Now cosine we have to find the theta. Cosine is measuring horizontal components, so that horizontally the value can be, value is here. That is square root of 3 over 2, the positive value, and now negative square root of 3 over 2, that value. So you have here this, the touching point, like that, so that you have this angle and that angle from positive square root over 3. From negative square root of 3, you have this angle and that angle. So it has 4 angles. And because of a symmetry, after finding one here, you can get easily the other 3. Right? Okay, you can do it. Now, for that problem, and I put here the hint, and because it's cosine, sine combined, so it's not easy to deal with. So we have to unify the cosine or sine. Now cosine squared theta is same as 1 minus sine squared, and we replace that portion to 1 minus sine squared. So 1 minus sine squared theta minus 3 over 2 sine theta equals 0. And we multiply minus 1 to obtain that 1. Then now, if we are choosing x equal sine theta, then the equation will become x squared plus 3 over 2x minus 1 equals 0. Of course, this quantity is always between minus 1 and 1. Okay? Now, by using quadratic formula, you can get the solution here, x separation. And now that is, okay, maybe 2 and 1 half. So that is minus and plus. So here, that equation can be written here, x plus 2 and x minus 1 half equals 0. And so that we have x equal minus 2 and half. However, this one is out of the domain of x, so that it cannot be used, which means that x plus 2 cannot be 0. Okay. So now, x is 1 half. That is the same as x is sine theta, so that you have to find the theta such that sine theta is half. Again, you can use here circle of radius 1, and then here now, and sine is measuring the vertical component, so that here you are making, oops, half will be around here, that way, so that this angle and this angle. So once you can find this one, then the other one can be found by using symmetry quite easily, right? Okay, and that is the end of the section. Thank you.